All right, today we are going to talk about what's called compound inequalities. So just like in English, if you have a compound sentence, that's when you have two or more sentences put together with a conjunction of some sort. So for example, I am a math teacher and I'm a girl. For example, that's a compound sentence because it's two sentences put together. That's the same thing for inequality. So it's two problems really combined into one. Now there's two types of compounds. There's the and statements, but then there's the or statements. So we're going to start here with the ands. An example of an and statement is if I said, give me a number that is more than 2 and less than 6. So again, pick something that's bigger than 2, but also smaller than 6. And there's some numbers that fit, right? So we would call that an and statement. Now, we don't write the word and when we present our answers. We actually represent it like this. So if you read this correctly, you always read from the middle outwards. So on the right side, this would be pronounced numbers less than 6. On the other side, and this is sometimes what throws kids for a loop, again, you want to read it from the middle outwards. So you wouldn't say x is less than 2, you would say x is greater than 2. So 2 is less than x is greater than 2. So this really does mean numbers that are greater than 2, but also less than 6. Now you can put that the other way. You can write it like this. So again, if you read it from middle outwards, x is less than 6, x is more than 2. I am going to tell you that when I do my work, I always present my answers like these. I'm just a fan of always putting the smaller number on the left and the bigger number on the right. So I like to always present my answer like that. So notice that when you go to write an and answer, your letter's in the middle, you have a symbol on each side, and they both point the same direction. And then smaller number on the left, bigger on the right. All right, now when you go to graph this, it's very simple to do. You're going to put a 2 on your line. You're going to put a 6 on your line. Now it says you have to pick numbers greater than 2. So because that's not underlined, we're not going to color that dot in. And it's the same thing with the 6. That is not underlined, so we did not include 2 or 6 in our answers. You must strictly be bigger than 2 and smaller than 6. So 2 and 6 could not make this statement true. All right. Our next type of statement are what we call or statements. So for example, a number cannot be more than 5 and less than 2. So if I said, give me a number that's bigger than 5, but also smaller than 2, you're not going to come up with anything because everything that's bigger than 5 is also bigger than 2. Now if we change the word and to or, now it's an answerable question. If I said, give me a number that's more than 5 or less than 2, now there's lots of answers. Just like if I said you have to use a red pen or a blue pen. So you can use a red pen. You could also use a blue pen, but you're not going to do both, right? So it's the same thing here. All right, so ors get presented like this. You cannot combine them into one single phrase because they don't have anything in common. I want my numbers to be bigger than 5 or less than 2. You can't be both, right? So when you go to graph these, again, these are not inclusive phrases. They're not underlined. So you're going to do open circles again, but this time they go away from each other. All right, so a little way that I try to get my students to memorize this is to think of these as relationships. So the and statements, those would be like people that stay married and they never split up. The or statements, they're not so fortunate. They're the people that it couldn't work and they have to go their own separate ways, just like these guys. We couldn't agree, so we go our own separate ways. Maybe for the better, maybe for the worse, but that's a good way to try to remember the rules of each one. So the first thing we're going to do is just practice turning words into math. It says write each of the following as a compound inequality. That means I want you to turn all this into symbols and letters and numbers. So we have an and statement. All right, when you have an and statement, your letter will go in the middle, and you will have a symbol on each side, both pointing the same way. Your smaller number goes on the left, your bigger number goes on the right, and you're done. I do not underline these because the phrase more than and less than don't have or equal to in them. So it's got to be strictly more than 3, strictly less than 9. Right, now number 2 says or, so I'm not going to put these together. I'm going to write the word or. Right, you have to write the word or if it's an or problem. And then we're just going to turn this into symbols. So we have X. The phrase is at least means greater or equal. And then we have a 5. Now this phrase right here, less than, means this symbol. And then you have a 2. Notice they did not exactly specify what is less than 2. So that's when you have to realize they're still talking about X. It's no different than if I say, I like chocolate and ice cream. I don't have to say, I like chocolate and I like ice cream. I can just say, I like chocolate and ice cream. So they expect you to know that they're still talking about X. And you don't put those together, you just circle it, that's your answer. You can either be above 5 or below 2. There's no number that's going to make both of them happy, so they can't come together. Right. Number 3, you can see that word and. So again, we're going to put the letter in the middle, an arrow on each side. The smaller number goes to the left. The bigger number goes on the right. Now we just have to decide if we should include -3 and 2 as answers. So if we look at the word minimum, that's being used for -3. Think of a sentence that you've heard where you've heard the word minimum. For example, you have to be a minimum of 18 years old to be considered a legal adult. So what about people that are 18 years old? Are they adults? Yes, they are. Okay, so that's an inclusive phrase. So we would accept -3 as an answer, and we would also accept 2. The next thing we're going to do is just copy those answers onto these lines, and then we're going to graph them. So we want to make sure we know how to represent our answers on a graph. So we're just going to copy this down real quick. All right, now when we go to graph, we're going to put 3 and 9 on our number line. And it doesn't matter how far apart they are. You can do that how you'd like. 3 should have an open circle because it's not underlined, and neither is 9. And then just like P is in between 3 and 9, that means you want to circle all numbers between 3 and 9 or shade all numbers between 3 and 9. Okay, so that's your graph. Right, our or statements are going to be opposite. So I'm going to put 2 and 5 here. It looks like 5 gets a closed dot and 2 gets an open dot. And then, unlike the ands, the ors go their own separate way. All right, so let's try the last one real quick. We have a -3 and a 2. This is inclusive on both ends. So solid dots. And the ands stay together. They do not go their own separate ways. So that's at least an intro into compound inequalities. In our next lesson video, we're going to go ahead and do some solving so you can see the process in which that has to occur.